to adjust the microphone. Okay. Yeah, my name is Tatum Eigenberger. I'm in the Frisk Lab at Stony Brook University, and I'm a second-year master's student. And today I'll be talking about my study of population dynamics of weakfish in the Peconic Bay Estuary. So a little outline of what to expect from the talk. I'm first going to state my objectives, go into the background about the species weakfish and the location of the study in case anyone is unfamiliar. And then I'll talk about the methods for the data set I'll be using and my model production, and then the results and discussion of the results and possibilities for future research. So the objectives were to evaluate and explore, specifically to evaluate recruitment and growth of juvenile weakfish in the Peconic Bay Estuary, which is their northern range, and then to explore environmental and climatic drivers of weakfish growth and recruitment. So some background, weakfish, they are found from Cape Cod to southern Florida, but their primary range is considered to be New York to North Carolina, and they are managed as one stock across this entire range. Even though they're also thought to have natal homing. So weakfish are a migratory species, and they move inshore and northward in spring into estuaries and nearshore habitat to spawn and grow throughout the summer before they move offshore and southward in the fall. Locally, they are a beloved species. I'm not from the East Coast, and I learned quickly how local fishermen love the weakfish and how they once were so large and abundant, and now they no longer have successful commercial and recreational fisheries as their population has been in decline for quite a time, especially since the 90s. A little bit about the Peconic Bay Estuary, which is where my data comes from. It's located between the North and South Fork of Long Island, and it's an excellent habitat for spawning and juvenile growth. And it's especially interesting for our study with weakfish as, like I said earlier, their primary range is New York to North Carolina, so it's on that northern range limit. The data set that I am using for this study comes from the New York State Peconic Bay Small Mesh Trawl Survey, which is run by the DEC and was commissioned by the Atlantic States Marine Fisheries Commission with the purpose to look specifically at weakfish recruitment. They also do collect data on other species as well as the environmental conditions. But yeah, it began in 1987 and is still running to present day. And they sampled 16 stations, randomly selected. They sampled those weekly, May through October. And you can see in the image, each square is considered a station. From this data set, I have taken weakfish fish length and the environmental conditions that were sampled. So, in order to evaluate weakfish recruitment and growth and to explore the potential drivers of recruitment and growth, I produced GAM models. First, we separated the data set into adult lengths and young of the year lengths, with adults being greater than 170 millimeters and young of the year being less than 160 millimeters. Then I used the GAM package in R to create the generalized additive models using forwards and backwards selection, and lowest AIC is how we picked the best model. So potential predicting variables that were included in both the growth and in just the recruitment model were temperature, salinity, dissolved oxygen, second depth, spawner abundance from the Peconic Bay dataset specifically, as well as spawner abundance from the ASMFC 2019 Weakfish Stock Assessment Update Report and NAO and AMO. And then for the growth model, the potential predicting variables were total chlorophyll, temperature, DO, second depth, young of the year abundance, and NAO and AMO again. So this is the young of the year abundance that we took out from the data set within the Peconics. So you can see that it has been increasing in recent years, but it's also a lot lower than what it was in the earliest bit of the survey. It's kind of up and down throughout the data set. And then here is the adult abundances. So the top graph, I have the adult abundance from the data set within the Peconic specifically, and the lower graph is the adult abundance across the entire range from that stock assessment update report in 2019. And just note that the y-axes are on different scales, but the trends are clear, and that's what I was really looking at. The trend of the adult abundance within the Peconics, you can see since about 2008 is increasing, and the trend of the entire population has been, again, decreasing since the 90s. So opposite within the Peconics versus their entire population. Here are the results from my recruitment model. The predicting variables that were retained after model selection for recruitment are temperature, salinity, NAO and AMO, Secchi depth, and dissolved oxygen, as well as the ASMFC assessment spawner abundance. The local adult abundance was not retained in this model. And with this, I want to point out how there was a regime shift found within the Peconics that happened from 1999 to 2000 when the AMO changed from a cold to a warm period. And once it switched to the warm period, we can see in these recent years it has a pretty strong increasing trend in recruitment. So just a bit more about that regime shift. It was a change to species assemblage in Peconic Bay, again from 1999 to 2000. Warm water species such as weakfish and summer flounder were replacing cold water species like winter flounder, winter skate in the community. And this regime shift was found to be driven by the AMO and NAO phase change. So that was that cold changing to warm. Here is my results for the growth rate model. We calculated average daily growth rate in millimeters, and that is the black dots on the graph, the red being the predicting. And the predicting variables that were retained in the model after model selection were temperature, salinity, NAO, and Secchi depth. So NAO was included in both, but there wasn't as strong of a reaction, I guess, to that regime shift, that phase change in the growth rate compared to recruitment. But growth rate looks, I'd say, relatively stable throughout the data set and maybe increasing in the very most recent years after 2015. So in conclusion, our results suggest that weakfish recruitment in the north is driven by physical variables and strongly influenced by NAO and AMO. Weakfish recruitment is increasing while growth appears relatively stable, and there is that plausible transition in recruitment aligning with that regime shift that was found to have occurred in 2000. Some future directions for the study, I would like to get some mortality estimates. I would like to evaluate changes in timing of recruitment throughout the data set within the Peconics. And I also have an acoustic telemetry study that'll hopefully be able to tell us when weakfish are coming into the system, when they are leaving, and if any are returning year after year. And with that, I want to say thank you to my lab and to the DEC with the data set, and for you guys for adjusting to the time change. So, any questions?